This is A. Radhika. I am going to discuss power electronics video lecture on working of chopper in four quadrants. In last class, we discussed about the concept of chopper circuit, type of choppers, control methods of choppers, applications of choppers. Today, we are going to discuss about the classification of choppers, operation of choppers in all four quadrants. So, in this, first we are discussing about the classification of choppers. Choppers are mainly classified into 5 types depending on the direction of output, means load voltage and load current. So, in this, the choppers are classified into 5 types, that are class A, class A chopper, class B chopper, class C chopper, class D chopper and class E chopper. In each class we have the some explanation. So first we are going to discuss about the class A chopper. In this will be, it will be in first quadrant. The output voltage is positive and current, the output voltage is positive and current also flows in positive direction, means here V naught and I naught is in positive direction. Hence, it is also called first quadrant or class A chopper, means here the output voltage and output current will be in positive. In class B chopper, the output voltage is positive and the current flows in negative direction. Hence, it is also called second quadrant or class B chopper. Just we can watch in waveform. This is the second quadrant. Output voltage is positive, output current is negative. In third class, the output voltage is positive, whereas current flows in both the positive and negative directions. Hence, this type of chopper operates in first and second quadrant, are called class C chopper. So, here the output voltage is positive and the output current will be positive direction and also it is in negative direction. This is the class C chopper. It will be appears in quadrant 1 and quadrant 2. This is the class D chopper. In this, the output voltage is operated in both positive and negative directions, but the current flows in positive direction. Hence, it is operated in first and fourth quadrant. Here, the output voltage is positive and negative and the output current is only in positive direction. This is the class D chopper. Finally, it is the class C chopper. In this chopper, low voltage and current flows in both positive and negative directions. Hence, it is operated in all four quadrants and called class C chopper. So, this is the uh, four quadrant chopper. The output voltage will be positive and negative and the output current will be positive and negative. So, these are the classification of choppers. Now, we are going to discuss about the operation of chopper in all four quadrants. So, this is the diagram for chopper in all four quadrants. So, here in this we connected four chopper circuits and along with we can connected four diodes for each chopper, and it has the load, inductance, load, and here is the output voltage and here is the some induced EMF and is the output current. So in this circuit at load, the load is the middle between series two, two choppers and series 2 choppers that are parallel. So, for load each side, one chopper will be conductors. When the pulse width modulation signals are applied to some choppers, that time the choppers will be work. When the chopper will be off, the diodes will be conducts. Now we are going to discuss in briefly about the uh, operation of choppers in all four quadrants. So here, so in this, so in this, the operation of chopper in all four quadrants, the figure, this figure, the power circuit diagram for a four quadrant chopper, it consists of four semiconductor switches CH1 to CH4 and 4 diodes D1 to D4. Here the input voltage current are Vs and Is. Vs is the input voltage and Is is the input current, and the output voltage and current are V0 and I0. V0 is output voltage, I0 is the output current. This is the operation of conducting devices. In first quadrant, this is the in first quadrant for this figure, for this figure in first quadrant, the thyristor CH1 is operated, the CH1 and CH4 is on, means chopper 1 and chopper 4 is on. CH, in case of CH1 is off, then CH4 and D2 will conduct, the from D2 will be conduct. In second quadrant, CH1 is operated, CH1 D4 on, L stores energy, inductor stores energy, CH2 and then D1 D4 conducts. In quadrant 3, chopper 3 operated, CH2 CH3 on, CH3 off, then CH2 chopper 2 and D4 conducts. In quadrant 4, CH4 operated, L stores energy, CH4 off, then D2 D3 conducts. Is the operation of chopper in all four quadrants. Now we are going to discuss clearly here the operation of chopper in first quadrant. For this operation, CH4 is on, CH2 and CH3 are off, and CH1 is operated. When CH1 and CH4 and chopper 1 and chopper 4 conducts, I0 flows from source to load and the output voltage is equal to input voltage. When chopper 1 is off, load current freewheels through chopper 4 and diode 2 D2. Thus, both load voltage V0 and current I0 are positive. It is first quadrant operation. Operation of chopper in second quadrant. For this operation, chopper 2 is operated while chopper 1, chopper 3 and chopper 4 are off. When chopper 2 is on, the negative current flows through L inductance chopper 2, D4 and E. The inductance L stores energy during the time chopper 2 is on. When chopper 2 is off, current is fed back to source through diodes D1 D4 as the feedback energy E plus di by dt is more than the source voltage Vs. Thus, The voltage V0 is positive and current I0 is negative. It is second quadrant operation. In third quadrant, for this operation, chopper 1, chopper 4 and chopper 1 and chopper 4 are off, chopper 2 is on and chopper 3 is operated. When chopper 3 is on, the load is connected to the source through chopper 2, chopper 3, and both output voltage, output current are negative. When chopper 3 is turned off, the negative current freewheels through chopper 2 and D4. Thus, the load voltage, output voltage and output current are negative. It is third quadrant operation. In fourth quadrant, the polarity of EMF E is reversed for this operation. In this fourth quadrant, the operation is polarity of EMF is reversed. For this operation, chopper 4 is operated and the chopper 1, chopper 2 and chopper 3 are off. When chopper 4 is on, positive current flows through E chopper 4, D2 and L inductance. So, energy stored in inductance L. When chopper 4 is off, current is fed back to source through D3 and D2. Thus, the load voltage V0 is negative and current I0 is positive. It is fourth quadrant operation. So, before going to end of the class, we will watch one YouTube video regarding classification of choppers.
Four quadrants by appropriately selecting the arrangement for the semiconductor devices depending on which quadrant they are operating, whether it can be single quadrant or multiple quadrants. They can be classified as type A, type B, type C, type D and type E choppers. Let us see each one of these choppers in detail now. So first type of chopper is also called as the type A chopper or the first quadrant chopper. So this chopper we have already discussed. This is nothing but same as the step down chopper. So in this chopper, why it is called as the first quadrant? The reason is if you are taking the I0, average value of the output current and average value of output voltage, you will observe that both V0 and I0 will be positive for this case. So that's why it is called as first quadrant chopper. So basic circuit diagram will be similar to this one. This is my supply voltage. So supply voltage is connected to your load, that load through a switch. So this switch is the thyristor switch and across your load one diode will be connected which will be used for freewheeling purpose. That means to continue the conduction I0 even when the switch is open, it will continue the conduction. Let us see how this will operate. Initially when the switch is closed, when you are closing this switch like this, when this switch is closed, so the current, this entire supply voltage is directly connected across your output. So your output voltage will be positive which is equal to your supply voltage Vs and now the current will start passing through your load. So now when the switch is open circuited, when the switch is opened after the on time, so what happens? The current, because there is an inductor in the load, inductor will not allow the sudden change in the current. So now inductor want to continue the current in the same direction. So polarity of voltage across the inductor will be opposite or the reversed. So because the polarity will change like this, lower side will be plus, top side will become minus. So this diode, freewheeling diode will be forward biased and current will start circulating in this loop. So the current will start circulating within this loop. So your output voltage, because whatever voltage is the inductor, that voltage will drop across the resistor. Or for ideal diode, we know voltage across the diode is 0. Same thing is connected across your load. So that's why your output voltage will be 0. But the current is positive. It will continue in the same direction. That is when CH1 is open, I0 is positive, V0 is 0. the current passes through the freewheeling diode. So in this case, the net power is positive, because if you are taking this V0 and I0 as my reference, so either this V0 I0 are positive or 0. That means always the power, which is the product of V and I, or the product of average voltage into average current, will always be positive. That means we can tell that always your supplies or the source supplies the power to your load. Only one way transmission is there. So that's why this can be used only for the motoring mode. It can be used only as a load. Power cannot be supplied back. So the formulas and other things, how to calculate these things, are already discussed in the step down chopper topic. If you want the detailed analysis of the formulas and other things, you can please refer there. So now coming to the next type of chopper, which is called as a type B chopper, which is also nothing but the second quadrant chopper. That means the characteristic will be in the second quadrant of the VI characteristics. So this is also called as the step up chopper. So step up chopper is already discussed. Same working principle will be here. So I am discussing this one also briefly. So here only condition for this type B chopper is your load should have a DC source. That DC source can be either battery or it can be a DC motor where some back EMF is induced in that. So here the basic working will be like this. Initially when the switch is closed, CH2 is closed, because there is a source, this source will circulate the current through this chopper. So when the current is circulating in the chopper like this, you can see the current is circulated through the chopper like this. So automatically this entire voltage will drop across the inductor plus the resistor. So here inductor will oppose the change in the current. So polarity will be like this, plus minus. So the inductor will start storing the energy. That means the energy is stored in the inductor now. So the current is passing through this one. So now when the switch is open circuited, after the time t on, when the switch is open circuited, now what happens? The current cannot change suddenly. So now the property of the inductor is it will oppose the cause. That means in order to proceed the current or pass the current in the same direction, its polarity will be reversed. So now this inductor voltage or voltage across the inductor will add the voltage of your battery or voltage of your back EMF to supply the current through your source. So how the current will be supplied? The current will supply from through the E through L resistor, and it will be supplied through diode D2 to your supply. So in this way it will pump back the energy to supply. I am repeating once again, when the thyristor is closed, the current will freewheel in this circuit. That means this E will freewheel through this chopper. It will freewheel through this switch. So now because of that the energy is stored in the inductor. So the energy stored in the inductor will be dissipated through the supply, or it will be supplied or pumped back to the supply when this chopper is open circuited. So now from 0 to T on, what will be the output voltage? Because it is closed through this chopper switch, across this chopper the voltage is 0. So your output voltage is 0, and the value of I0, because the current is passing opposite to the reference direction of I0, that means we can tell I0 is negative. So from the duration of T on to T, again the current continues in the same direction. So I0 is opposite to reference direction. So that's why it is negative. Now coming to the voltage, now you can see this entire set is now connected across your supply. So that means the voltage V0 will be nothing but equal to your supply voltage, or we can tell that V0 is more than the supply voltage. That's why it is pumping back. So or otherwise we can tell that V0 is positive. Here the V0 is positive. So same statement I have mentioned here. When CH2 is open, energy stored in L aids in E to maintain the current in the same direction, and hence supplies the current back to the source through the diode D2. Okay, so here you can see the operation is happening in the second quadrant. Voltage is either positive or 0, but the current is always negative. So as the current is negative, so that's why it is in the second quadrant of the operation. So this type B chopper can operate only in the regenerative braking mode. You can see the power is not supplied from the source to your load, only the power is supplied from your load to the source. Only one way transmission is there. Power is always negative. That means it can be used only for regenerative braking mode only. So this type A and type B chopper, whatever we have discussed, they have the common negative terminal between the input and output circuit. This is not the case for the remaining choppers which we are going to see. Let us go to the next type of chopper, which is a type C chopper, which is not discussed before. So here onwards, let us try to discuss in detail. So this is also called as a 2-quadrant type A chopper. This is just the combination of the type A and type B chopper. That means two choppers, type A and type B, are connected in parallel. So here one thing you have to remember, that here the connection will be, when you connect them in parallel, it will be like this. There is chopper 1, this is the chopper 2. So this is the switch 1, switch 2. Two diodes, anti-parallel diodes are there, D1, D2, and load is there. So load is the RLE load. So here this is CH1 and CH2, these two switches should not be turned on simultaneously. Anytime they are turned on simultaneously or simultaneously both are in the on condition, so your entire supply is shorted through these switches. So because of the short circuit, what will happen? This entire chopper will damage. So that's why you have to take the precaution. Either chopper 1 will be on or chopper 2 will be on. Both will not be on simultaneously at any instant. That care you have to take care. Let us see how this will operate. So when you are operating the chopper 1, in association with the diode D1, it will act as a step down chopper or type A chopper. You can see here, when the chopper 1 is closed, the current passes like this to your load. And when this is open circuited, then it will continue to freewheel through the diode D1. This is type A chopper. So in the type A chopper, we know the output voltage will be positive or 0, but output current is always positive. This is the type A chopper. Now coming to, if you are operating the chopper 2, so chopper 1 is open, so CH2 is closed. When the CH2 is closed, what happens? This will freewheel through this chopper 2 or through this switch 2, and when this switch is open, this energy stored in the inductor will be pumped back to your supply or supplied back to your source. So that means it will pass through diode D2. So CH2 in combination with D2 will operate as a type B chopper. So type B chopper means the direction of the current is negative. Voltage can be positive or 0, but I0 is negative. So the combination of these two, what is happening? The output voltage V0, average output voltage, can be either positive or 0. It can be either positive or 0, but whereas the current can be positive or negative. It can be this side or this side. So that's why it is occupying both the first quadrant as well as the second quadrant. As it is having both the quadrants, that means, because in the first quadrant power is positive, in the second quadrant power is negative. That means your load is supplying power back to your supply or the source. So that's why this can be used for both motoring as well as the regenerative braking of DC motors. So wherever application you have the DC motors for regenerative braking application, we always go for the type C chopper, which is the combination of type A and type B choppers. So then the next type of chopper is called as a type D chopper. Type G chopper is also called as a 2-quadrant type B chopper. So this is also similar to the previous case. Here little bit changes are there. This is also suitable for both motoring and regenerative braking. Here power can be both positive, negative. Only difference is, previous case the current can be positive, negative. V0 is positive. Here V0 can be positive or negative. I0 is positive. Only that is the difference. Direction of the voltage, polarity of the voltage will change, but current will remain the same. So how this will be there, you can observe here. So in this case, this type of chopper operation is different. Simultaneously, both the chopper should be on or off in this condition. Let us see how it will operate. So when you are closing both the chopper 1 and chopper 2, what will happen? Your supply current will come like this. It will come like this. When the choppers are closed, it will pass like this. Okay, this is the case when these choppers are closed. So this is for the case of first instant. That means CH1 and CH2 are on. V0 will be, because it is directly connected like this through the chopper. So V0 is nothing but your supply voltage, or we can tell V0 is positive, and current is also passing in the same direction. So I0 is also positive. So now when the chopper CH1 and CH2 are off, when both the choppers are off, so in that case what will happen? Because the property of the load is it cannot change the current suddenly, because it will have the inductor generally. So that's why to continue the current in the same direction, what it will do, it will start passing the current like this. That means through the diode D1 and this diode D2, it will supply back like this. In this way the current will pass. So this is the case for the CH1 and CH2 are off. So that means because it is passing like this, you can see this negative terminal of your supply is connected here, and this side is connected to the positive terminal of the supply. That means your output voltage is opposite to the reference direction, or we can tell that V0 is negative And what is the value of the I naught? I naught is positive. I naught is positive. So it will pass from D1 to load to D2 to Vs. In that way it will pass. So you can see the waveform here, same thing. When this thyristor CH1 and CH2 are turned on, so during that case your output voltage is supply voltage, it is positive. When they are turned off, your output voltage is negative, it will become equal to minus Vs. Again when it is turned on, it will be plus Vs. Like this it will go. So similarly, if you are taking the output current, so whenever the thyristors are connected, because supply is now connected to your load, so the load current will goes on increasing. Inductor will start storing the energy. It is storing the energy. Now when the thyristor is turned off, now inductor will start discharging the energy or supplying the energy back. So the current will goes on decaying like this. Again increase, decrease. Getting it? So now coming to the current supplied from the source. The current supplied from the source, you can see initially the current direction is same as the reference direction. But when during the off period, what is happening? It is passing through the diodes. That means the current direction is opposite. That means during the turn off period, current direction is opposite. During the turn on period, current direction is positive. So now calculating the value of the output voltage, we can calculate the output voltage is, for how much duration it is there, you can see this is nothing but Vs for a duration of T on, Vs for a duration of T on minus Vs for a duration of T off, because this is in the negative direction, divided by average you have to calculate, so T. So this I can write as Vs into T on minus T off by T. So now you can see under different conditions. So first one, if the value of the T on is greater than T off, when the value of T on is greater than T off, so T on minus T off is positive. So we can tell that the output voltage will be positive. Output voltage is positive. And if we calculate the value of alpha, the value of alpha will be greater than 0.5. The value of the alpha will be greater than 0.5. So in that case, we can tell that V0 is positive. We can tell that the V0 is positive. So let us take the case if T on is less than T off. If T on is less than T off, in that case the value of alpha is less than 0.5. So we can tell that the V0 is negative. Alpha is the ratio of T on by T. So when T on is greater than T off, so that means T on is greater than 0.5, 50%. So that's why alpha is greater than 0.5, V0 is positive. When T on is less than T off, then alpha is less than 0.5. So V0 will be negative. And when T on is equal to T off, in that case we can tell that alpha is nothing but 0.5. You can substitute here T on is equal to T off, then the value of output voltage becomes equal to 0. So we can observe here the output voltage, average output voltage can be either positive or negative or 0, but the current is always positive or 0. So current is positive, voltage is positive or negative. So that's why it is occupying the first and the fourth quadrant. So let us see the next and the last type of chopper, 4-quadrant chopper or type E chopper. So this type E chopper, the name itself is telling 4 quadrants. That means it consists of 4 semiconductor switches. That means CH1 to CH4 and 4 diodes D1 to D4. They are connected in anti-parallel with the switches. You can see here, this is switch 1, switch 2, switch 3, switch 4 are connected like this. Across these switches in opposite direction, the diodes are connected. This is diode D1, D2, D3 and D4 and the load is connected here. These are my reference polarities of the output voltage and the output current, and your supply is given here. So here this numbering of the switches are done intentionally. So the numbering of the switch CH1, CH2, CH3, CH4, these corresponds to which corresponding quadrant of operation. That means when you are using the CH1 for turning on and turning off, it will turn on for some time, turn off for some time. Then in that case, it will operate in quadrant number 1. Similarly, CH2, quadrant 2, CH3 is quadrant 3 and CH4 in quadrant 4. Let us see the operation, how they will operate. So first one is the first quadrant operation. So to operate in the first quadrant operation, in this operation, the CH1 should be operated. That means it will turn on and turn off. But here, CH4 is permanently closed. Here CH4 is permanently kept on. It is permanently closed. Which switch is varying now, turning on and turning off? Only CH1. CH1 is operated, and here the D2 will act as a freewheeling diode. So if you are drawing the equivalent circuit to this one, it will have the CH1. The CH1 I have represented here, and this diode D2 is connected across the load through CH4, is connected across the load through CH4. CH4 is closed. I think this circuit you can see. So this circuit you can observe that it just resembles the type A chopper, which we have discussed before. That means it will behave as a type A chopper. Type A chopper means output voltage will be either positive or 0 and current also will be positive or 0. So that's why I am not going to the explanation. So in this case, as the both average voltage and current are positive, output power is always positive. So only motoring mode is possible. So now coming to the second quadrant operation. So for operating in the second quadrant of operation, because second quadrant means regenerative braking. So in order to operate in regenerative braking, that means load supplies the energy to your source. That is possible only when there is a source in your load. That means the load should have either a motor where the back EMF is generated, or it should have some battery source. Then only the second quadrant is possible. So in the case of second quadrant operation, only CH2 is operated. Only CH2 is operated. Let us see the operation. When the CH2 is closed, then the current will pass from, because this is the direction of E, because E will start discharging through this CH2. So E will start discharging through the CH2. It will pass like this through the D4. It will circulate. That means the equivalent diagram I have drawn here. This E will start discharging through your CH2 and D4. It will start supplying the energy. So when it is supplying the energy, you can see this entire whatever voltage of E is there, that will drop across the inductor. So now inductor will start storing the energy. The energy is stored in the inductor. So now when the CH2 is open circuited, now current will try to decrease. The property of the inductor is it will not allow the sudden change in the current. So in order to aid the current, what will happen? The polarity of the EMF in the inductor will become opposite. That means it will become plus minus like this. This is E. So now your resultant value, you can see at this point it will be more positive compared to the second side. As this is positive, diode D1 will be forward biased. As this side is negative, diode D4 is forward biased. So it will start conducting like this: diode D4, E, L, D1 and supply. That means now energy stored in the inductor is now supplied back to your source during this duration. So this is just similar to the type B chopper we have already seen. So now, so it will operate in the second quadrant only. Next one is the third quadrant operation. So if you want to operate in the third quadrant operation, how it will be done? CH3 is operated, because third quadrant I told you chopper 3. Because that number indicate which should be operated. CH3 is operated and CH2 is permanently closed. CH2 is permanently closed. That means your negative terminal is always connected to your positive terminal of your load directly, always. That means this negative terminal is always connected. So same thing I have represented, it is connected to the load. So now when the CH3 is closed, what will happen? This CH2 through the load, that CH3 is closed, it will pass like this. So your positive supply is connected to CH3 to your load, and this is connected to the negative terminal. So now how the current will pass? Because this positive terminal is connected like this, the current will pass like this through your load, through CH2 and return back. So you can see the actual current direction will be opposite to the reference current direction, and coming to the voltage direction is also opposite. Voltage direction is also opposite, current direction is also opposite. That means you are getting V0 also negative, I0 also negative. So let us see the case when the CH3 is open circuited, what will happen? When the CH3 is open circuited, in that case, whatever is the load is there, because the current cannot change the direction instantaneously. So the current direction will continue to pass in the same direction, because this load will have the inductance. So how it will pass? CH2 is already closed. So load current can come like this CH2. As it is passing like this D4 will be forward biased. It will start freewheeling to this diode D4. So you can see the load is freewheeling through the diode D4. So in this case also, as it is freewheeling through the diode, so output voltage is 0 and the current is in opposite direction. That means I0 is negative, V0 is 0. So you can observe in the third quadrant operation, or by using this operation, we will get in the third quadrant. V0 is negative, I0 is also negative. V0 is also negative, I0 is also negative. Next, coming to the last one, that is fourth quadrant. How to operate in the fourth quadrant? CH4 should operate in this case. So CH4 is operated, and second one, the direction of the EMF, that means the EMF source that is there, will be opposite to case of the type B chopper. Or type B chopper, here E is like this. So this side is plus, this side is minus. So in that mode, it will operate in fourth quadrant. So let us see how it will operate. When the CH4 is on, There is a CH4, this is the CH4. When CH4 is on, this battery will start discharging through the CH4. Through the diode D2, it will freewheel. Through the diode D2, it will do the freewheeling like this. So that means the battery, whatever is there, it will start supplying the energy to the inductor. So the inductor will start storing the energy. Your output voltage will be, because this entire voltage drop across the inductor, or net voltage will be equal to 0. V0 is 0, and the value of I0 is, it is in the same as the reference direction. That's why we can tell I0 is positive, and inductor stores the energy. So now when the CH4 is off, when the CH4 is off, the current direction cannot change simultaneously. The current direction cannot change simultaneously. So in that case, what will happen? CH4 is off. Inductor aids E in maintaining the same current direction, and hence supply the power to the source through the diode D2 and D3. Through the diode D2 and D3. Through the diode D3, it will supply back. You can see here, it will pass through your D2, D3, and it will supply back to your source. So in this case, you can see, as it is supplying, diode D2 and D3 voltage drop is negligibly small. So your output voltage, you can see, is opposite to your supply voltage, because you can see output voltage reference plus is connected to minus. This reference minus is connected to plus of your supply. That's why you can tell that voltage, output voltage can be negative or 0, but output current is always positive. So that's why this operates in the fourth quadrant. So in this way, it can operate in any of the four quadrants. I hope that different classification of the type of the choppers are clear to you. If you still have any queries, you can leave your.
So now we watched the YouTube lesson regarding choppers working in four quadrant. So today we learned class A, class B, class C, class D, and class E choppers, and also operation of chopper in all four quadrants. Here we have the few quiz questions and a few frequently asked questions. Thank you. Tomorrow in next class we are going to discuss with another topic. Thank you.